Awesome. Welcome everyone to All Core Devs number 222. What a nice number. I am filling in for Tim today, who will be gone for the next few All Core Devs until the end of the year, and then he'll be back to take back over. Yeah, we have I think in a not too full agenda for today, just quite a few items, but they're all relatively minor. So let's just get started. So the first up will be a few Fusaka items. The first of which is any devnet updates. Do we have any devnet updates? Anyone here?
Yeah, so earlier today we launched a Fusaka shadow fork, Sepolia shadow fork, and so far it's been pretty uneventful, I guess. We've already gone through Fulu and BPO1, and BPO2 should be in like half an hour, and we don't seem to have any missed blocks or any problems. We've only done a consolidation so far. We're gonna still do top ups and exits to make sure that all of that looks good as well. But while working on that, Barnabas found a few issues with the BPO schedule that he's also trying to bring up on ETH R&D, but I will let him continue with updates and bring up that topic, I guess.
Yeah, so the general problem is that as we start including the named forks in the blob schedule in the Genesis JSON file, this will make basically the generation of the Genesis file very, very complicated due to the different values, the BPO values can be set. Because as soon as we start adding Amsterdam and Istanbul and Bangkok and whatever else future fork we're going to have, we're going to need to have logic for using the latest BPO values that are currently used. And on top of that, add the named fork in there as well. Even though that those named fork values will change no values whatsoever, because on the CL side, those named forks cannot adjust the blob values anymore. So they are basically redundant fields, and I'm proposing that we should probably get rid of the Osaka field as well as Amsterdam and all future forks as well.
Any comments on that point?
Yeah. I've argued against this multiple times because I think it's much better to be very expressive with how these configurations, like it's better to be expressive about the configurations than to like implicitly force the users to know, okay, like I don't know, now we have two named forks, but none of them have any blob schedules. So I need to look 3 forks back to the last BPO to see what blob schedule to apply to the current fork. And that is one of the things. And the other thing is that we are limiting ourselves to never do BPOs. To never do blob schedule updates on named forks. And I think that is also something that, I don't know, like we never really discussed this, and it's very weird that the CL teams have made that decision that they cannot do blob schedule changes on named forks anymore.
But they can. So like you could have a block schedule change as well, but you would just basically schedule Amsterdam and you would schedule BPO6 on to the same time slot on the ER side, and you would schedule on the same epoch on the CR side. You would just not use the exact same name to schedule the block schedule change.
So maybe there's a bit of a diff that we need to explain. So on the EL side, you're very explicit. I agree with you, Marius. You can look at one place where everything is scheduled, which is how it is today. But on the CL side, that's not the convention. So in the CL, if there's a fork and you don't append the value with the fork name, then you reuse the value from the previous fork. So what would happen today is we would have a blob change with Pectra, and then you apply all the values for the BPO 1 to 5, and then it's sort of implicitly understood that Fulu has not changed the blobs. But if we decide to change it at the next fork, then Glamsterdam would have an appending as well. So it's somehow really weird in the CL logic to do it. And the easiest way to sort of prevent that is to say we're only touching the blob schedule with BPOs, and then it's consistent again. And that way it would be consistent on both sides.
Yeah, I don't like it, but it seems that I'm the only one arguing against it at this point, and it's not really a big change, so I guess we can just do it.
Also with Dustin's point, even in the future, if we intend to change the blob parameters, we don't have to schedule it at the same epoch as a fork. We can just schedule it 10 epochs later if we want to.
And just as a clarification, sorry, I have no context on this. Would this be something that we would then also already change now for the Fusaka rollout, or like going forward?
There's not really anything to be changed, right? It's just how the clients interact with the config that they are given.
And whether they're expecting specific values in specific fields or not.
Okay. But the config for Fusaka itself wouldn't change, or like sorry. Okay, yeah. I see. Okay, so then do we want to, like, it sounds like Marius is was the only one. I mean, I saw Raul in the chat with some reservations as well, but do we just want to make a decision now, or is this something we want to keep discussing?
I would just like to point out, I misunderstood what Marius was saying. I agree with Panda Op's suggestion here, but I also wanted to bring up the fact that the EIP, that was the original intention, that the CL would list all all blob parameter changes, regardless whether they belonged in a regular fork, a name fork, or BPO fork, in the blob schedule. And it's actually, there's a statement in the EIP as well. It might have been overlooked, but yeah, I just posted it in the chat.
Also, this won't really relate to any changes that has to happen for Fusaka. This is just at most would affect the block level access list branches, which are devnet branches anyway.
I see. Makes sense. Yeah, sounds like the majority view was to then go with that, right? Of course, we can continue to discuss offline, given that there's no direct fork implications. But yeah. Okay, then I would move to the next point, which is the Holešky status. Is there anything to report from that side?
Yeah, so the BPO 1 went live, I want to say 2 days ago. And I think there was one peer-to-peer thing on Lighthouse that's still being triaged, I guess, or already has a fix in a future release where they were losing some peers around the BPO boundary. But other than that, I don't think there was anything to report. Yeah, I would be interested to hear what the client team's monitoring has said, though.
Anyone here that can speak to that?
Sure. I can describe. So essentially, we Nimbus have run into some resource issues on low core machines. It happens to be that the way, and this didn't show up on Fusaka devnets because they were run on with more resources, relatively speaking. But effectively, we don't. The way we happen to run our testnet nodes, they don't have that many cores, and because and somewhere around the 9 to 15 BPO change in Holešky, they started consuming enough CPU time, and we've benchmarked this, and it's just how much time the library takes to do this. There's not really Nimbus specific in this part of it, but it takes like 4 seconds to reconstruct on the supernodes, and that just doesn't work anymore with the 1.5 effective cores. So we're figuring out what to do with that. But it's definitely an issue with a novelty to BPO1 as a result.
Okay. Yeah, little to report from folks, always good. So then we can move on. I think the next point was Alex wanted to briefly talk about the blob submission API. If I remember that correctly, Alex, are you on the call?
Yeah. Can you hear me?
Sorry,
Hello?
yes. Go ahead.
Okay.
Yeah.
Thank you. Yeah, no, just been having audio issues. Anyway, so this came up in the context of some of the rollups, getting ready for Sepolia. And the question here was just how different clients will treat essentially, I think what we're calling legacy blobs or transactions with the pre-Fusaka approved format and the new one. So I just wanted to check in, just so everyone's here, and I think we could just get a quick update or status on how this works for each client. But essentially, yeah, when I guess the question is, do any clients have support for converting between the old proof format and the new one? Like, let's say there's the question of the fork boundary, but let's just say post Fusaka, yeah, what's the behavior here?
Yes. So what we discussed this for a really long time, and I'm pretty sure what we ended up with is at the fork boundary we start converting in the background our own blob pool from blob proofs to cell proofs, and we convert all of the transactions that we get sent via RPC from blob from blob proofs to cell proofs, and I think we stop accepting blob proofed transactions on the networking.
There we have a small window in which we are still accepting from the network. I think it's 3 hours or something.
And then would you, at some point into the Fusaka fork, stop converting on the RPC? I think that'll be the main thing for the rollups.
No.
Okay.
Like not within like the next 1 or 2 releases would we remove that conversion.
Gotcha. And I think Geth was special in this way, as in this is what Geth does, but I think other clients essentially just drop support. So it'd be nice if I could just get a confirmation of that.
Yes, for Aragon, we just drop support of blob proofs, non-cell proofs. Yeah, we are not as nice as Geth.
In Nethermind, we will not gossip and like accept such transactions with all proofs. right on when head is post Osaka, we will drop them from text pool, but will allow re-entrance of the transactions of the same transactions, but with a new version of the proofs. And I guess someone maybe from Guess has some information about whether such conversion in like tough conditions when a lot of transactions are in the pool, will such conversion lead to any luck of the client or not?
So we tested that, especially this case on I think Holešky, on like the last fork, the last testnet fork, and yeah, basically nothing happened. We are only converting them in the background, and we are also limiting the conversion so that we don't overrun the node. But what we did, or what the PandaOps team did at the fork boundary, they sent a bunch of transactions so that our mempool was full, and yeah, we converted them no problem, it seemed.
And you do not, okay, so you do not drop transactions for some time from the pool, just start converting it. And if a new node is connecting, will you gossip transactions that are not yet converted, still not converted, and have all proofs, or not?
Yeah, we are not sending without proofs. So after the fork, we only send with new proofs.
Thanks.
That was the question.
Yep.
Okay, were we missing any client, or Alex, did you?
Well,
Any others?
Basu and Reth, but I think they have the behavior that, yeah, others that Geth had. So I think we're good.
And that was all you wanted to discuss?
Yeah, I just wanted to know where people landed as of now. I'm talking to some of the rollups just to make sure things are good on their end, and that should be enough for now. Thank you.
Awesome. And just one quick clarification, Marius, when you said and you'd keep the conversion functionality until at least 1 or 2 releases after. In principle, not sure if this is at all relevant, but in principle, if there was any L2s or so that would approach you to request extending the support a little bit, would you be open to that, or?
Yeah, we don't have a clear path to dropping that yet, anyway. So, yeah, we will be in contact with the L2s to drop it at a point that is convenient for everyone. But I would also urge basically everyone that's sending blob transactions to update their code as soon as possible to create those cell proofs themselves, because otherwise you're creating a proof and then we have to recreate the proof in the node again, and so we're wasting a bunch of time. So if you want to get your transactions in faster, create the proofs yourself, the cell proofs, the correct proofs.
Yeah, that makes a lot of sense. Awesome. Perfect. Then I think that was all on that agenda point. Then anything else on Fusaka people want to discuss before we move on? Okay, then we have a quick single item section, which is just scaling updates, where we have some brief comments from Joachim, I think, on some state access benchmarks that he's looked into. Is that right?
Yeah, thank you. Yeah, so I wanted to talk about Camille, and Camille from Mastermind and we are working on tooling to run execution spec tests against like state snapshots, like mainnet snapshots. So we can actually also incorporate the size of the state in these tests to perform performance benchmarks. And this is of course very broadly applicable because we can also like test for different gas limits. And what we actually want to do here, like what our holy grail would be, is if we see a slow block, then we want to check this block, see if there's anything weird going on over there. We will then isolate this behavior, and then we would replay this on top of, well, most likely it could of course have something to do with the state it runs against. And if we would then run it in isolation, we would also like to see that we can reproduce this slow block in isolation, so we can really take apart the client to figure out, okay, what is like the bottleneck here, so we can optimize the client. For these slow blocks, well, I think I've mentioned that many times already, but yeah, most of the times when a slow block is being reported, it has these very big Xen transactions in it, so a transaction which interacts with Xen, which has a high gas limit. And we are currently testing this, and one of the current results is that if we do this on top of mainnet state, that we rerun this like a lot of changes to the storage of Xen, then we still do not see really problematic numbers here. So this either means that the tests are wrong, or our tooling is wrong, or that we are missing something else. But yeah, I just wanted to bring that up, that this is the current research we are doing for the state access benchmarks.
Sounds good. So basically, if I understand this correctly, because I heard that from some of the test cases there were some relatively slow performing numbers, right, around some of these cases. But what you're saying is that at least right now, it looks like this might just have been a discrepancy in the testing process and not necessarily correctly expressing real kind of performance bottlenecks.
Yeah, somewhat. So what I'm actually saying is that if we run these tests in isolation, the numbers there do not look super bad. But if we look at slow blocks on mainnet, especially those reported by, how is it called again? Like we have a Grafana dashboard, which has slow blocks. And these are being accumulated from the lab, from EIPs. And I think so far I've only seen blocks with these Xen transactions in them. And this begs the question, like maybe the result is that we do not have, we cannot reproduce these results in isolation, but that will then mean that these nodes, when they are live on mainnet, there is something else going on, but that suddenly causes like somewhat like a majority of these nodes performing like slow blocks, which we can't yet reproduce. So yeah, that's the current state of this research.
Okay, then I did basically exactly backwards. But okay, awesome, perfect. Then I think that's good point for follow-up work. But yeah, thank you for reporting this.
Yeah, I see one question from Amazing. Yeah, we are running this on I don't know the EIP number, but like the specified hardware specs.
Okay, so when you say in isolation, what does that mean exactly? It just means that you are running that specific block on top of that snapshot, but the snapshot has like the whole database, right? The whole blockchain and state database, right?
Yes. Yeah. So what we actually do here is for these these specific Xen situations, is our hypothesis is that this has to do with the storage rights to Xen. So what we do is we create a test which should actually perform worse, because what we will do here is we would fill the entire block with storage rights, and we even optimize like this contract to do the storage rights to squeeze out even more storage rights than what would happen in the block which we have seen. And then when we run this, and by running this in isolation, I also mean we are starting our client without dev P2P, like we are not going into the network. We are just only starting the client to run this specific block. And if we do that, we do not see like this execution bottleneck. Or well, not a bottleneck, but we do not get like these slow results as we would see on mainnet, which is like being reported by multiple different nodes that this block is slow. But if we run it again, which we would just say is like an even worse case than the mainnet block, we do not get the results which we would expect.
Maybe one test that can be interesting is to run all the time one node on the same hardware specs that is basically running mainnet. And then when we have like one slow block on that, like with that hardware, we can pick up that slow block and run it on the same hardware in isolation. Because from what I understand, like the blocks that you get from, I think from the network, from ETH Ops team can run on different hardware types, right?
Yes. Okay. Yeah, that's also a very good point, of course, that could also be hardware related. Yes. Yeah.
Yeah, I think part of the reason we don't want to over-index on just nodes that we run is then you're kind of canonicalizing an architecture and optimizing for a specific architecture. One of the benefits of relying on the contributor data set is we are basically getting all types of nodes that people run in real world on mainnet as free data points. But yeah, it is harder to reproduce, of course.
Yeah, and one question actually about that, because I could not see on the lab, we can see like the consensus layer clients, but we cannot see the execution layer clients, like their types. Is that correct?
We should have the data on a database. Maybe we can ask on a thread, and Sam or Andrew should be able to pull it out of the data.
Let's do that. Let's do that. Yeah, sounds good.
Awesome. Any other comments now by codevs on this? Otherwise, maybe Joachim, also where would the best place be for people to jump into that kind of work and conversation?
Yeah, just either send me a message on Discord or Telegram, or yeah.
Okay. Then I would move on to the Glamsterdam section. We have a few items here. First, a few general ones, and then regarding EIP proposals. So first, on general, do we have any devnet updates? So primarily that's block level access list. Tony, are you on the call?
Yes, I can provide a quick update on block level access lists. So we had a breakout call yesterday. Things are in general looking quite good. Beso, Geth, Ref, and Nethermind are very, very close to being interop ready, I would say. So it's just a matter of time getting those clients to interop, and Aragon is also getting there. Regarding devnet, I would pass to Stefan, who has better insights what the next steps are there.
Hey, can you hear me? So
Yes.
generally, I've been trying out individual kurtosis testnets with just individual execution layer clients, and I've been able to run Geth, Besu, and Red, just one client each time. But I haven't been able to run any clients like Mix, like Besu and Red. I haven't been able to run them together. So I'm still trying to get that working with clients. And Nethermind, I haven't been able to run. There is a small issue with the Genesis, and I posted that into the block level accesses channel. But in general, I think we're getting very close. Maybe next week, if the interop starts to look a little bit better.
Let me also give you an update on the state of tests. We released our latest test a few weeks ago with about 26 tests. Since then, we've been tracking test results for get, nethermind, and ret, and they're roughly passing about 80% of the tests. There's a particular test which was failing for all 3 clients, so we double-checked it to ensure that is okay. Besu is also passing tests locally, but they're fixing an issue with the Hive. So I think those should also be available. So that's 4 clients in total. Since then, we've merged a few more PRs, and there are about 54 tests ready for BAL. Some of those tests have variations. So in total, we have about 154 scenarios that we're testing. So we'll have these ready in an upcoming release soon.
Sounds good. And sorry, this is a dumb question. Is this block level access specific or tests across the?
Yeah, specific to block level access, yes.
Okay, perfect. Anything else on block level access lists?
Yeah, maybe one more thing just to add. There's still one PR open around 7702 about handling the authority tracking there correctly. This isn't merged yet, but is about to be merged very soon. So it's correct in the EIP, but it's not yet correct in the specs. And I got a PR open there, and Philippe and me are working on this right now.
Sounds good. Katja?
Hello. Yeah, we also started working on metrics for block level access list. That would be great if some of the clients at least started implementing, or we can communicate on this. So probably, if not for DevNet 0, but for DevNet 1, we could have something already. Thank you.
Awesome. Thank you. Then in terms of DevNet updates or feature updates, anything from the EPBS side? Obviously, that's more consensus layer side work. So just checking, is there anything execution layer side that would warrant an update? Otherwise, yeah, as Alex is saying, there's a breakout. I assume you mean for EPBS, right? EPBS breakout tomorrow.
Yeah, I was just saying, yeah, we have the breakout tomorrow if people want to attend there.
Yeah, and I think one of the topics raised on last OCODEF, so maybe for those that were not on there were some questions around the unconditional payments, specifically whether there should be some sort of splitting it into separate EIP or something. Yeah, if that's a topic that interests you, tomorrow would be the breakout. Yeah, awesome. And I agree with Justin in chat. Great work all on these kind of Glamsterdam features already. It seems like we're already well into the work on this fork. We haven't even gotten Fusaka out the door. This is great. Yeah, then Glamsterdam next. Well, I had testing updates, but I assume that's already covered now with the block level access specific testing. Was there anything else on testing for Glamsterdam beyond that we should cover, or I assume this was it? If nothing else, then then for the rest of the call, we just have a few more updates on proposed EIPs and new proposed EIPs for the non-headliner section of Glamsterdam. Just before we do that, a reminder: we had said that basically once we set the mainnet date for Fusaka, we will basically freeze the proposal window for Glamsterdam. We haven't done it yet, but obviously we're getting close to that point. And then on that last OCODEFs, on the ACDC side, we specifically clarified the details of what the exact timeline there looks like. So the idea is that whatever point in time we actually do set the mainnet dates for Fusaka, that then basically that will trigger one last week of proposal window for non-headline EIPs for Glamsterdam, and then basically the deadline there would be then 1 week. So basically the core devs, the OCODEFs call 1 week after that mainnet date setting one. That way, hopefully, people have time to get in the last moment proposals. With that out of the way, we have three people that wanted to briefly talk about some of these proposed ERPs. The idea would be that in next ACDE call, so in 2 weeks, we would really go into the discussion more generally about what kind of the non-headliner section should be focused on. But for now, it's still just about informing people about the individual proposals. So it's not necessarily meant as a governance discussion section or a technical information section. First up would be Maria, who wanted to briefly talk about an update on the repricing ERPs. Maria, are you on the call?
Yes. Hello. I'll just quickly
Perfect.
share my screen. I have a few slides to help with the discussion.
It's still loading.
Okay, can you
We
see
can
it?
see your screen.
Perfect. Okay, so I will just give a quick overview on the repricing EIP. So we have quite a few now. And just to say that before we list the EIPs, I wanted to just give an overview of why we are even doing repricings. So the first point is like we know that EVM operations don't have harmonized costs at the moment. So for instance, on the compute side, we have operations that take show different performance in terms of million gas per second. We on, for instance, state creation, not all operations have the same cost per byte created. So this creates a situation where we have like specific bottlenecks that sort of limit us on how much we can scale instead of just having everything harmonized. The second point is that even if the costs are harmonized at resource level, the relative cost of resources will likely change with balls and EPBS. So for instance, we may have more time for execution, but the state growth, we don't want it to increase at the same rate. So we want to keep state growth stable while giving more space for compute. So the relative cost there also changes. And finally, as we increase the gas limit as we are scaling, this will put pressure on these persistent usage resources, which are mostly history growth and state growth. So we also need to take this into consideration when we are doing the repricings. Now on to the proposed EIP. So I just want to say that EIP 8007 has the full list. So if you ever want to check which EIPs are changing pricings for Glamsterdam, you can check there. But this is mostly an informational EIP. So we are not, this is not the bundle, like we are still discussing them one by one and considering if we should include one by one. Is just a place where you can have a quick view of all the EIPs and their status in the governance process. And so on to the various EIPs. So first on the compute and memory side, we have 7904. This is the big repricing on compute operations. That is, so we are using benchmarks on each operation to harmonize their costs, and also this will likely lead to a decrease in most compute prices with likely some exceptions on some precompiles. But essentially, this is a massive reprice on compute operations, and most of it will be making them cheaper. We have 7667. So this is updating some operations based on the hashing cost for zkVM proving. So this is sort of an EIP that it's not directly related to increasing scaling, but it's something we might need down the line when we are moving to the zkVM, and it's something we need to also account when we are working on the 7904 to make sure that these changes make sense and are consistent. And finally, we have 79 to 3. And here Charles is going to give an update, but essentially we are introducing a new model for memory and also updating the price accordingly. On states, we have 8032, which Guillaume will also give an update next. And essentially, this is just repricing S-store in a way that takes into consideration the size of the contract storage. So essentially, is making larger S-stores to larger contracts more expensive than to smaller contracts. And then the next two EIPs are the 8037, which is changing the state creation cost. So this is targeting state growth. And it's proposing an increase of around 10x on the state creation costs. And also adding an independent metering for the cold deposit components. And 8038, so this is focused on state access costs, and also it's sort of connected with the tree-based storage, but is doing a more holistic reprice on all state access, and also taking into consideration if 8003 is included, then they will kind of work together. So the 8038 will simply change the constant part of S-store and leave the dynamic part with the contract size scaling consistent with the EIP. On data, we have two. We have 7981 that is introducing a floor to access lists, and also 7976 that is further increasing the cost for call data. A point here that is important, so we have for data and state growth, these essentially are mostly independent resources from the execution and state access resources. And so it's important when we are setting the values here to make sure that things are consistent with a certain gas limit anchor, let's say. So we are not introducing more mispricings. And finally, we have two more general or accounting EIPs. So 2780 is proposing to reduce the intrinsic costs. So essentially making it transfers cheaper, but also adding a component for account creation. So when an ETH transfer is creating an account, essentially it will be more expensive. And then finally, 7778 that proposes to remove the refunds from the block limit accounting. So they will still be a refund to the transaction, but they will not count for the block limit. So this should help us remove some worst case blocks that are making those cases not as worrisome. So on the next steps, first is just making sure that we are considering all mispriced areas and see if there's anything else we should be adding before the deadline for EIP proposal. So if you have any thoughts on this, just reach out to me, and I'm happy to discuss it and support any more EIPs that need to be drafted. We also are working now with opcode benchmarking, and this will help us set the final parameters for some of the EIPs and also updating a few parameters that need updating. And also we need to make sure on this step that, again, as I was telling, to have the alignment between the various EIPs and making sure that things are consistent and make sense. And then after this, the next step will be to start implementing these new price changes in all the clients and then running gas benchmarks. So we make sure that the worst case scenarios are covered and we are not introducing more mispricings. And also another big part here is like this is one of the biggest repricings that we've done in a lot of time. So it's important for us to really investigate backward compatibility issues and making sure that we are not introducing anything that could break important contracts or yeah. And so here on this point, like if you have any thoughts on what could break, also please reach out to me so we can we can work on these together. And this concludes the presentation. I was not seeing the chat, but I will stop now the slides.
Yeah,
and
there were, I can maybe just read them out to you. There were two, I think, main questions. Well, one is just very practically. Charles was asking what the best way for people would be to reach out to you for feedback on these topics.
yes, so I'll say Telegram is a good place. So I can put my handle if you don't have it in the chat in a bit. But yeah, just Telegram is probably the easiest.
Sounds good. And then Matt specifically asked you, you already touched on this a bit, on the question of backwards compatibility. Is there already ongoing work? Like, is this maybe different EIP by EIP? So what's the current state of this basically?
Yeah, so I think on a couple of EIPs that were either making things cheaper, usually the analysis was there's not a lot of concerns there. I think the biggest concerns are actually on probably the state growth and state access ones that will have an increase. And on there, we do have some analysis planned, but it's still ongoing, so we don't have any results yet. Guillaume, do you have anything to add here?
Now on this topic, I have something to, I mean, I want to talk about EIP. Yeah, okay. Let me proceed. I have two things going on. The first one is that 2926 is not in the list, and it is definitely addressing the state growth in terms of code. And I'm also quite surprised to discover AT37, which is very redundant with 2926. I've also seen and unfortunately Carlos is not here today, but Carlos was asking me to review something that I thought was going to be AT37. Where is it still evolving that? And this is the supposedly definitive version.
Your sound broke out a little bit, so you are asking about AT37?
AT37, yes.
Yes.
Okay, I'll just, I assume that was Telegram taking over the sound. Let me turn it off. Yeah, so two things. The first one is that 2926 is very redundant with AT37. And it seemed to me that AT37 was going. I reviewed the document by Carlos, who unfortunately is not here today. That was to be, I thought, the future version of AT37. So I'm just asking, is it the final version?
This version is the most updated version. We may need some parameter changes down the line, but this should be the and some more so improving sections on specs and backwards compatibility issues, but this should be the final EIP. I would say that the main difference there is that this EIP is not only focusing on contract code, but is also focusing on other components like account creation and so on and so forth. And I think we can make both EIPs compatible. So the biggest thing is like AT37 is really focusing on an harmonization of state growth in general for all operations that touch or increase state. And I think both EIPs are kind of they work together, so you can have both, or you can have just one or the other. So it's I don't think it's like if you have one, you don't need the other. They are kind of so they have implications to one and the other, but they are not exclusive, let's say.
Yeah. Okay. I would still like to get, but I will talk to Carlos. I'd like to get to the bottom because I reviewed something on Tuesday that was quite different. So I'd like to make sure I understand. But yeah, okay, we can take that offline.
Good. Any other comments on the presentation or any of the individual repricing ERPs? Okay, and yeah, I saw Maria now put her Telegram handle in the chat, so you can find it there. Then I think we'll move on for now to the next item, where Guillaume, you'll be up again talking about EIP 8032. Sorry, before that, just one more. I saw Tony had his hand up. Sorry about that.
Yeah, sorry to interrupt. I just had a question, like, how would we best proceed with the repricing EIPs? Usually we have like client teams shortlist their preferred EIPs. Yeah, is there some different process involved because it's like a bundled repricing thing?
So just to clarify, I think Maria did a good job summarizing this already. Basically, why there is this extra informational EIP, which was a bit of an experiment as the form factor, but there is no specific bundling. So obviously, some of them make sense together, and we can point this out and talk about this a bit more, I think, in 2 weeks. But in principle, we can pick any and none and all of them, basically whatever we choose. In terms of process specifically, my idea was, and I'm happy to feedback if people think this is a bad idea, my idea was to say, start the conversation properly next OCODEVs or ACDE, so in 2 weeks, around what should be the priorities, how much room do we think we have in Glamsterdam, like what is the different categories of the EIPs that basically were proposed. So to have some sort of baseline of what do we expect Glamsterdam to look like, and then on that basis have some EIP specific discussions, and then move to the step of having client teams assemble their preferences. So basically, like today, still focus purely on just the technical presentations of the individual EIPs. Does that make sense for people? If not, of course, this could be adjusted. I like the most reasonable approach to me. Sounds good. Then I would for now stick with it. But again, also feel free to reach out to me. We can discuss some alternative approaches to this as well. But yeah, then for now, Guillaume, you're up.
Yeah, okay. I hope you guys can see my screen or my window. Yeah, I'd like to talk to you about EIP 8032, which indeed stems from all the conversations about state access or state related operations repricing. So there are very simple goals for this thing. We want to limit the state growth. We also want to make sure that no individual contract, and there's really one that we're thinking of when we say that, is their individual growth is reduced. And then, of course, we would like a smooth transition as much as possible. So yeah, like the idea, there's a big math formula inspired by the yellow paper, but it's very simple. You just write down into the account what was the maximum depth that was written to previously into this account storage tree, and then we target an activation depth, which would be targeting that same contract that was talking about, but maybe other contracts if they happen to grow just as large. And then the new gas cost for writing, which is a store, would be simply to take the delta written in the account, which is loaded at the beginning of the block execution. And then you have this constant value, which is today's value or any value that is decided after the repricing EIP. And then you just get the delta divided by this delta 0 power of 16. And then you take the floor, like the the smallest integer down from this number, and multiply by another cost constant. The idea is that everything that is below this delta 0 will not see its cost changed at all, and everything above, so that contract, will see its cost increasing exponentially. Yeah, how does the transition happen? It's just that from one block to the next, at the end of the block, you just look at, for each account, when you recompute the storage root of this account, you just update the value, the delta value of this account, the maximum depth, and then you don't update it with a new value, you just gradually increase one by one, so that the cost of those contracts that are already much larger than the limit increase somewhat progressively. I mean, it's going to be probably 9 blocks, but it's still going to be a bit smoother. And yeah, maybe we can modify this conversion to, this rule to be even more disincentivizing of the state growth as a whole. So do the same thing, but add a gamma, which is the total state size. And we do have, at least in Geth, we did implement something to keep track of the total state growth. It's not exactly what we need, but it's close enough that we could modify it to be that. And then we would have a second term in that equation, where not only the specific contract will be penalized for growing the state, but even those who are not this big contract but have to suffer from a larger state growth, they will see their costs rising up. So it's much more dynamic. And of course, we can modify those constants as machines get more powerful, as state, maybe if we implement state expiry, we could also decrease them. So yeah, that's just an idea, but it's not part of the EIP at this moment. So just wanted to also say what it's not. It doesn't tell us what the gas costs are going to be. So some of those EIP, like especially AT38, AT37 maybe, and all those EIPs that focus on the gas cost itself, this is not, this is orthogonal to that. It also doesn't work on limiting account creation per se. It's just the storage size. I would say 2026 addresses the code size aspect, but yeah, there's nothing for account creation. Yeah, like I said, the code bloat, yeah, that's 2026. I have one last slide. Yeah, it's what is left to be done. So I did implement that in Geth. It's still in draft mode because I haven't figured out the activation yet, but it doesn't really matter for testing. What we would like to do is get the constant value. So piggybacking on what Maria was saying, try to see if we could use EIP, any of the EIP in 8007 to figure out what the values are, and also decide on the gas formula. I presented two, so pick one of the two. Yeah, that's it for the presentation.
Thank you. There were a few comments in chat, specifically one conversation was around how are you thinking about using the worst case for pricing? Is this not vulnerable for attacks, where someone can basically like maliciously create one really like deep sub branch in the storage tree, and then forever that contract has to pay more?
Yeah, so I mean, this is more explained in the EIP. So let me refer you to the EIP. But no, you can't really do this because the activation depth is going to be 9. So that's pretty expensive to get this depth voluntarily, because it's like the storage slots are stored. You know, the keys are hashed before. So to be able to get that deep, you're going to have to create either a lot of keys, which is going to be expensive, or do a lot of proof of work to address to reach that depth. So no, it's not an attack.
Makes sense. And then one more conversation, but there were several different people talking about it, but I would summarize it maybe as if you have multiple accesses, then if they're in the same storage tree, even if it's a bit deeper, then they amortize basically because they are in the same tree and partially share the same branch. Whereas if maybe you now incentivize, which in principle is a good thing, people to split it up into several contracts so that in each contract it's less deep, but then they no longer basically have this amortization. So basically, do you think this is a concern that maybe the efficiency gain in a way can be less in these cases, or that basically it's kind of, yeah?
I didn't quite understand the question. What would the efficiency decrease?
So basically, someone like Fotos, for example, said was there an explanation why one contract of size 2s is worse than two contracts of size s? And of course, this is only relevant if they're actually being accessed. So imagine you have now someone basically that otherwise would have a contract of size 2s, now splits it up into two contracts of size s, and we have a block with simultaneous accesses into both contracts. And in the old world, that would have been just one with two accesses into the same storage tree of one contract. Is this new pattern more efficient now, or is it not?
I mean, if you want to do this, it's not going to be that much more efficient because to access your second slot, you're going to have to call the contract. So it's going to be expensive to do this. But yes, you could do this. And in fact, this is more or less what we want. And the reason for this is because you would be able to expire things. I mean, we're still counting on getting state expiry to work. So it would actually be exactly what we want, that people split their data into several contracts, but somehow doing the union of all the contracts, that's going to be very expensive. So it's going to disincentivize state growth this way.
Sounds good. And then, of course, also people can also speak up. I don't need to read all those comments, but Matt asked, how does this ERP relate to the unification of the state tree?
Yeah, I mean, if the question is, can this still work with the unification with a unified state tree? Yes, it can. And although I forgot how it was going to work, but we came up with a scheme to make it work. So that's not a problem. The other I was thinking of something else. So if you're talking about doing the transition, this has no impact because yeah, it's not going to change the structure of the tree, and it's not going to block the tree from being converted into a different tree.
Sounds good. Any other questions or any questions from the chat that I missed that someone would want to answer from Guillaume? Okay, awesome. Well, thank you, Guillaume. I personally think this is a very interesting idea, although of course I'm supposed to be impartial. Then next up, we have Charles with several EIPs that he wanted to talk about. Just given that we still have 25 minutes of time, but I would ideally say that it would be nice to try to time box it a bit below that, to not because it's 4 EIPs, but basically like keep it up by going through them to just so we still have a chance of ending a little bit ahead of time. But yeah, Charles, are you on the call?
Yes. Hello.
Awesome. Then go
Can you
ahead.
hear me okay?
Yes, we can hear you.
Okay. I think a couple of these aren't that new. They've been proposed in previous forks, so I won't go over them that much. There's 7907 and 7903, which are alternative proposals, which were proposed for Fusaka. And they are about increasing the contract size, the EIP 170 24 kilobyte limit. And in Fusaka, 7907 was rejected because it makes some changes to the state, which are maybe hard to reason about. 7903 is an alternative which doesn't touch state assumptions about state at all. It increases the limit for init code. But that is just runs once and then it's never stored in state, so it's not an issue really. 5920 is pay, which I've proposed again for Glamsterdam, and that is the ability to send Ether directly to another contract without transferring execution context. 7923 is new for Glamsterdam, and Maria mentioned it. It's about changing the quadratic memory. Actually, I didn't realize there would be this much time today, so I prepared a presentation for 7791, which is the one I want to emphasize this call, so I'm just going through the other ones quickly. Yeah, 7923 is about changing the quadratic memory pricing. It proposes a paging model. So like, I guess, most other computers in the modern age, we can make the AVM have virtual pages. And this is super helpful for users and also compiler developers who can then use more of the memory space. So for example, if you want to have a heap and a stack, normally if you have, like with this quadratic memory, if you start from 0, then you can only have one stack or a heap, basically. Whereas in normal computers, you just allocate them in completely different areas of the memory, and then they grow separately. The one kind of contentious issue that I've gotten in private feedback so far is there's this kind of LRU cache, which is to help pricing. Basically, the 512 most recently accessed pages are cheaper to access because it reflects some reality of the underlying hardware, which is that if you have a thrash, so like either a cache thrash or what do you call it, a TLB miss, that incurs extra CPU time, and it tries to model that. But there's some discussion about this on the ETH Magician thread, and I'm a little bit open to changes about that particular model, that part of the model. But in general, I think that having page-based memory is good and important for the EVM. So I want to present on 7791, which is gas to ETH. Let me share my screen. Is this visible?
We can share. We can see your screen.
Great. I wonder how I can make this better. So making PowerPoints actually isn't one of my strengths. So this is mostly made by one of the LLMs. But it basically summarizes the EIP and then you go into some interesting parts about it. So the gas to ETH is actually a very simple opcode. Basically, it takes a gas amount and it pops it from the stack, and then it sends that amount of gas from the TX origin to the target. And the reason this is important is because basically every protocol or smart contract author runs into this issue of like, how do I get paid? And there's a lot of problems with getting paid. One of them, yeah, where do I even begin? So, and then people come up with all kinds of different ways to get around this, like they launch tokens or whatever. So some of the issues with like getting paid directly on chain are that the payment, there's no way to pay directly from TX origin to the contract that you want to pay. You basically have to like do payment hops. So like if you have a deep chain of contract calls, then you have to like forward message.value or forward some token down the entire chain until it finally gets to the target. And that's just kind of bad UX. because you have to like do a bunch of calculation. You have to make sure that the right amount of message value is passed and so on. So what this EIP is trying to address is that problem. So basically, it uses a concept that's familiar from UX, which is paying gas. Like everybody kind of knows that in order to keep the network running, you have to pay gas. And it uses gas to like kind of pay contract creators. So yeah, there's some kind of interesting technical issues that have been brought up with this so far. So one thing is that if you link it too close, oh, I wanted to point out there's another important thing about using gas, which is that instead of ether, which is that it's kind of actually priced in terms of block space demand. Very opinionated. Yes. So whereas ether is kind of has its own value or whatever, gas is usually actually priced in basically USD. So in some ways, its price is more stable, or it's like kind of it kind of aligns contract authors with the chain, because when gas prices go up, people who are paid with gas to ETH get paid more. So there's a few interesting things about the design that have been brought up. So one is that interacting with the burn is bad. So basically, the gas consumed by gas to ETH is actually very different from gas that's like consumed by regular opcodes. So gas consumed by regular opcodes, it like reflects some computational complexity, whereas this actually just reflects how much somebody wants to get paid. So you don't want it to affect the burn, because there are kind of griefing attacks. Like you can just like send a bunch of gas to ETH and you can like change the base fee or whatever. And it shouldn't like double accounting for how much is sent to Coinbase or whatever. So what we've done is we've created a separate gas to ETH limit, which is tracked separately from the regular gas. And that is slightly more complex implementation, I think, but it kind of sidesteps all of these issues with like how gas interacts with the rest of the protocol. Another thing is like how much gas are you allowed to send with gas to ETH? And there's a problem that has been correctly pointed out, is that like you can, it's like a griefing vector, like you can send an arbitrary amount of, you can spend an arbitrary amount of gas and do all kinds of clever things to avoid that showing up when you run ETH simulate. So the solution in this EIP is to like limit the amount of gas to ETH that can be spent, or the amount of gas that can be spent via gas to ETH, to the transaction gas limit. And that's kind of like some kind of reasonable limit. But I think the most natural thing to do is actually introduce a new transaction type, which might be in the future, but a new transaction type would by gas to ETH, maybe even by account. But basically, we left it out of the EIP because that could be more complex in terms of actually being able to ship the feature. So these are just some other things that are in the EIP that you can look up. Yeah, so this is also stuff that I mentioned. I think the main thing is that it gets spent by TX origin, which is like kind of the natural party that should pay for these kinds of on-chain payments. So here we have some examples of apps, and I won't spend too much time because I think everybody maybe kind of gets the point, and the time is limited, but these are just some examples so that you can like imagine what it can be used for. So one is like you have a DEX, you need to pay the protocol for the swap and then use gas to ETH, and then it pays the fee collector contract. And these are all kind of like actually in the same vein, which is like somebody created a smart contract and you want to use it and they get paid. This is another one. So the Oracle bridge callback. So you like pay an Oracle or you pay a bridge and then, sorry, you call an Oracle or a bridge, and then when you call it, the bridge or the Oracle operator gets paid. Something kind of like a SaaS contract. So these are like pay per function. So you want to use some kind of functionality of this contract, and in this particular one, then it does some whatever calculation and then pays the maintainer address and then finishes the computation and returns. And so this allows for like very what is it, like micro service, like super micro payments. Like you can like account for like how much should be paid at a very granular level. The gas cost model is kind of what you expect. It should like basically be the same as pay opcode. Yeah, I think this is a good place to end and take questions. There has actually been a draft implementation for Revin that was based on a previous version of the EIP, which several of these issues came up that I discussed. And there's also an RIP, the 7767, which has been proposed by Vectra for L2s to use. And that is something that operates in a kind of similar way. Okay, let me take a look at some of these questions. Interesting.
Yeah.
Or maybe I'll just say, yeah.
Chat's very mixed now because we still have also some conversation from the previous presentations mixed in between. Yeah, first of all, thank you for the presentation. Like just a quick side mention, one of the ones, not this EIP that you presented, but one of the ones you mentioned, the memory pricing one is also tracked by this repricing candidates informational EIP. So this is kind of out of that broader set of potentially doing some repricings. Concretely on this specific EIP, the gas to ETH one, do we have questions? I personally, I voiced some not concerned. Concern maybe too strong. I think it's interesting. But like it definitely feels like it's one of those high subtle implication changes. So for me it would basically like require like a high threshold of really understanding and thinking through the implications. But yeah, I'd be curious if there's comments. Ben, you have your hand up.
Yeah, I think it's quite interesting, gas teeth, because people do try and do it in practice, say with tokens, and you end up with like undesirable side effects where you'll take a fee in ETH if it's one side of the trade, or you take a fee in tokens if it's the other side of a trade, for instance. But then, as a result of that, you have to dump the tokens, which people who hold the tokens don't like. And then it also deals with the fact that if it's not something like a token swap where there's transfer of value, there are other contracts that simply can't factor in some kind of payment in an easy way. And also like what is it, the royalty thing on NFTs, that's like a sort of trust me, bro, we will pay you, but you could like build that in through this kind of mechanism. And then it sort of worked with ETH as money, I suppose.
That's a good point. Yeah, no, but I agree. Definitely also, that's why, yeah, it's definitely also very interesting. Yeah, anyone else also with any feedback on this EIP in particular?
Yeah,
Marius is. Oh, yeah. Okay.
Yeah, I had two questions that I put into the chat. One is, what would the interaction with the current AA stuff look like? And the other one is, how would the transaction format need to change?
So the transaction format, it doesn't need to change. So it's not in the CIP. It could be added in the future, but basically it would describe how much gas can be spent by the gas to ETH opcode in this transaction. It's a way for the user to avoid being griefed. But instead, in this version of the EIP, it's just there's a kind of a constant, I guess, a global thing, which is like it's just set to the transaction gas limit that's normal gas, if that makes sense. I don't know if there's any interaction with any AA things. I don't think so, really.
I suppose the issue would be if you bundled lots of transactions together, then one of the transactions could take more gas than, you know, if it's saying here's the gas for 5 transactions and one of them takes all of it. So it could be, there could be a bundling issue.
I'm not sure I understand about the bundling issue.
Well, because you're saying I want to send this, my first transaction is allowed to have 1 ETH, the second one 1 ETH, third one 1 ETH. But the first transaction would take all of the ETH because the transaction as a whole, this is how you could do in the gas fee.
Oh, I see. You mean how it interacts with the transaction limit?
Well, how it would interact with bundled transactions, which like AA would, yes.
I'm not sure I see the issue. Like that can be true for any kind of thing you do with bundling, right? Like you might not have enough gas to pay for all of the transactions in the bundle. That isn't the same as like when you
Yeah, it's because you're specifying the griefing limit per transaction.
Yeah.
So the transaction's composed of multiple transactions. So the first one
right.
can go up to the limit.
Yeah, and I would also say maybe
I think that would be like a problem of simulation.
Yeah, one related concern that I would have is that I think we very specifically discourage these days the pattern of sending bounded gas into subcalls, because that makes assumptions, implicit assumptions about details of pricing that we want to abstract away with gas abstraction, which means that in principle, kind of any transaction now is fully vulnerable to basically all like the gas being consumed for payment like this, which of course yes, in principle you can already. Oh yeah.
It's a separate budget. So that's one of the more recent changes to the EIP, which is that it doesn't interact with the gas used by the contract.
But then how can...
If it's a separate budget, it wouldn't need the transaction type, right?
The new transaction type would set the limit for the separate budget. But like, let's say that you have a contract call and it needs 100,000 gas, but the gas to ETH budget is separate. Like gas to ETH can separately consume 100,000 gas.
Yeah, I think we're getting now pretty into the weeds for this EIP, so we should probably take it offline here. But yeah, it's definitely an interesting concept. And again, there's probably a lot of skepticism you have to push through first, but it's very interesting. So yeah.
Yeah, I just Marius just said it breaks all gas estimation, but it doesn't. I'm happy to chat with you offline about this.
What's the best way to reach you? Like, what's the best kind of venue for discussion on this EIP specifically?
I can make a Telegram group.
That's good. There's also, I think I see on screen, there's a mini magicians thread as well on this EIP.
Yes,
I
there's
assume.
also an ETH magicians thread.
Perfect. Maybe someone find this and put this into the chat. That would be ideal. I'll also try to find it. Brownie points for the first person to do it. Perfect. Charles, you got your own brownie points. Perfect. Then yeah, thank you, Charles, and I would kind of end that section for now for here. Do we have, with in principle 3 minutes left, do we have any last topics that were not on the agenda? Anything someone would want to briefly bring up? Otherwise, we can wrap here. Yes.
Briefly, just a housekeeping item for PFI'd EIPs going into Glamsterdam. We've recently agreed to collect a primary point of contact for those. So if we, the protocol support team, will default to selecting whoever opened the PR to PFI that EIP, but we'll ping each of those parties for confirmation. So those names and Discord handles will be likely displayed on Forecast for the benefit of testing teams and PandaOps and so on.
Sounds good. Yeah, that's a really good initiative. And Forecast in general, like I said it off the air already, but like also for anyone listening, like go check out Forecast. It's amazing. Awesome. Then if there's nothing else, then thank you all. We ended up taking the full 90 minutes after all. As I said, in 2 weeks, we can start the Glamsterdam discussion properly. And until then, have a good time. See you all then. Bye.